Hello students, today we will solve some examples of finding complementary function when we have complex roots for auxiliary equation of linear differential equation with constant coefficients. So now let us consider this example. Find complementary function of, suppose we have this equation, d raised to 4 plus 8d square plus 6 operating on plus 16 operating on y is equal to some sin x. Okay, so solution, as we are finding complementary function, we have to consider only its homogeneous part. D raised to 4 plus 8d square plus 16 y is equal to 0 because we are finding complementary function. Now first step is we have to find its auxiliary equation. So the auxiliary equation is m raised to 4 plus 8m square plus 16 is equal to 0. The next we have to find roots of this auxiliary equation. So how do you find roots here? So this will have exactly 4 roots. They may be repeated or distinct roots, but it will have 4 roots because this is 4th degree equation. Okay, so here we can see all the powers of m are even. So let us put n is equal to, let's say, m square. So we'll get this equation as this will become n square plus 8n plus 16 is equal to 0, and this will give us values of n. So n will be minus 8 plus or minus under root 64 minus 64 upon 2. So values of n are, so we'll get repeated values here, minus 4 minus 4. Okay, so n is equal to minus 4 twice. That means this implies m square is equal to minus 4 minus 4. Okay, so which gives us m is equal to plus or minus 2i plus or minus 2i. So these are the 4 roots, plus or minus 2i plus or minus 2i. So we have plus or minus 2i repeated twice. So now we got complex roots. Okay, now next step is you have to find complementary function. So roots are plus or minus 2i plus or minus 2i repeated 2 times. Therefore complementary function is yc is equal to, so it is c1 plus c2x cos of 2x plus c3 plus c4x sine of 2x with this into e raised to 0x because the real part is 0. Okay, so which is same as c1 plus c2x cos 2x plus c3 plus c4x sine 2x. So this is yc for this differential equation. We got 4 complex roots, okay, plus 2i twice and minus 2i twice. So this is a complementary function. So this is how we can find complementary function for complex and repeated roots. Let us have one more example. Suppose we have this differential equation. Find complementary function of suppose we have this d square plus 1 cube into d square plus d plus 1 square y is equal to some, let's say 0 now. Okay, so solution. See, when we have right hand side 0, we have only complementary function. There is no particular integral for such differential equation. So complementary function will be the general solution in this case. So let's not go to that. We'll find complementary function only. Okay, so first step is you have to find auxiliary equation. So auxiliary equation is, so what is auxiliary equation here? Is m square plus 1 cube into m square plus m plus 1 is equal to 0. Next is we have to find roots of this auxiliary equation. Now see what is the degree of this auxiliary equation here? So it is m square plus 1 raised to 3. So here the degree is 6 for first term, and for second term it is square here, so 4. So the degree of this polynomial equation is 10. That means this will have 10 arbitrary 10 roots, and the solution will contain 10 arbitrary constants. So now we have to find all 10 roots. Okay, now look at here, we have this first factor here, m square plus 1 cube. Okay, so whatever the roots for this term, okay, those roots will be repeated thrice. Okay, m square plus 1 cube. So what are the roots for m square plus 1? So first consider m square plus 1 cube is equal to 0. This implies m square is equal to minus 1, and this is 3 times. Okay, 3 times. So this gives us m is equal to plus or minus I 3 times. Okay, that means plus or minus I repeated thrice. So we got 6 roots here, and in second case we'll consider this m square plus m plus 1 square is equal to 0, which implies, now when we solve this m square plus m plus 1, let's see what we get. So we'll get m is equal to minus b, that is minus 1 plus or minus under root b square will be 1 minus 4ac, that is 4 upon 2a. Sorry, so this goes as minus 1 plus or minus, that is under root minus 3, that is I times root 3 upon 2, and this 2 times. Okay, so we got, so roots are, let's write all the roots here. Roots of auxiliary equation are, what are the roots here? Plus or minus I, plus or minus I, plus or minus I. These are 6 roots, and then minus 1 plus or minus I root 3 upon 2, and minus 1 plus or minus I root 3 upon 2. So this is how we got all 10 roots here. Now next we have to find its complementary function. So therefore complementary function is yc is equal to, so plus or minus I repeated 3 times, so it gives us, now real part is 0, so e raised to 0x into, because the roots are repeated 3 times, c1 plus c2x plus c3x square into cos of, imaginary part is also 1, so cos x plus c4 plus c5x plus c6x square into sin x. This is for first 6 roots, plus now in second roots we have minus 1 plus or minus I root 3 upon 2 twice. Right, so real part is minus 1 by 2 and imaginary part is plus or minus I root 3 by 2. Okay, so therefore here we'll get e raised to minus 1 by 2x into, now we have root 3 by 2 repeated 2 times. Okay, so we already took constants up to c6, so now it is c7 plus c8x because roots are repeated twice, cos of root 3 by 2x plus c9 plus c10x sine of root 3 by 2x. Okay, now see, we got all 10 arbitrary constants. So this is a complementary function for this differential equation. Okay, it has, so the degree of this auxiliary equation is 10. We got these 10 roots here, and therefore this is a complementary function. So this is how we can find complementary function when we have complex and repeated roots. I hope you understood this. Try to solve some more examples on this. Thank you.